Hi, I'm Deepak from Reliant Institute of Oil and Gas. So today we are about to demonstrate penetrant testing in ASNT NDT lab practicals. So the penetrant testing is very common in major NDT methods because it is primarily used for identifying the open surface defects. So when it comes for the surface inspection, penetrant testing and magnetic particle testing and eddy current testing for surface inspection is very familiar. In that, very basic NDT method for surface inspection is penetrant testing. So today I am going to demonstrate how to perform the penetrant testing on a welded plates, T-joint, fillet weld, and this one is butt weld pipe, welded pipe. So in theoretical class you would have known that the procedure of doing this penetrant testing. So basic thing is we have to know whether the sufficient or adequate lighting is required to conduct the testing. So that is the first thing, and second thing is the testing temperature 5 degrees Celsius to 52 degrees Celsius. The penetrant testing is applicable, and the basic principle of penetrant testing is capillary action. The penetrant penetrates into the surface open or surface breaking crack, and it penetrates into the defect. It stays there, and we call it as a dwell time. And after the dwell time, we are removing the penetrant which is on the surface. Excess penetrant is removed, and after that we are applying developer. So based on the reverse capillary action or blotting action, the developer chemical which consists of a powder mixed with solution or solvent, and that developer, due to the reverse capillary action, it suck back the penetrant from the defect. And since the penetrant is having a color and the developer is bright white contrast background will be given by the developer, at the same time the penetrant is absorbed by the developer. So the penetrant is having a red color because I am using a solvent based penetrant or solvent removal penetrant. So I am going to conduct the solvent removal method. So the penetrant, since it is having a red color, so the indications will be developed as a red indications. So in indications, as per the theoretical session, we have discussed already that 3 types of indications: false indication, relevant indication, and non-relevant indication. So I am not going deeper into the theoretical portion. So I am just going to demonstrate how to perform penetrant testing or how to conduct dye penetrant inspection. So there are different methods: solvent removable method, water washable method, post emulsifiable method, and I am conducting solvent removable technique. So in the procedure DPI, dye penetrant inspection procedure, so the test object or the subject which is taken for the testing has to be pre-cleaned properly. So pre-cleaning followed by that application of penetrant. So we are using a penetrant aerosol can. So by spraying method we are applying the penetrant. So once the penetrant is applied, we are going to wait for 5 to 10 minutes, which is called as a dwell time, and the dwell time is the time taken by the penetrant to penetrate into the defect completely and dwells in the defect. And after the dwell time is over, we are going to clear or remove the excess penetrant from the surface, and then I am going to apply a developer which is a solvent based developer. So or it is also called as a non-aqueous developer. So first I have to clean, then apply penetrant, then wait for dwell time to get over. After dwell time, I am removing the excess penetrant from the surface properly, neatly. I should not see any traces of the color or any kind of stain of the penetrant. Then I have to apply the developer, and this develops the indication, and we can able to find the difference between the relevant non-relevant indications. So the first step, pre-cleaning. So I'm going to use, since the test piece is little bit corroded, oxides are there, so I'm using a thinner basic solvent. First I'm removing the major oxides, then I'm using a spot check cleaner or remover. Then after that I'm going to apply the solvent based red penetrant. So first I'm cleaning the surface. So I'm taking a cloth, I'm trying to clean the surface of the test specimen. So clean as much as possible in order to avoid all types of contaminants which can hinder the penetrant entering into the surface open defects. So I have cleaned the test specimen, which is T-joint fillet weld, and now I'm going to clean the butt welded pipe. I'm taking a new cloth. I'm using a solvent, higher concentrated solvent. So I'm cleaning the surface to avoid any kind of contamination, oxides. Okay, so now I have done the cleaning of surface. Surface is cleaned, pre-cleaning is over. Now I'm going to apply a penetrant. So while applying the penetrant, it is very necessary things to be followed, that the penetrant should be kept placed in a 45-degree angle, and in 1 feet distance from the test piece we have to apply the penetrant. So just one layer of spray is sufficient for the penetrant to indulge or interact with the material due to the higher capillary action. So I'm testing it. The test shot is okay. So now I'm going to apply, keeping it 1 feet distance, and now I'm applying it over the surface evenly. So see here, I'm going to apply it. So that's it. So this one layer is sufficient, and here also I'm going to apply. Okay, so I have applied penetrant on this material and then on the pipe. So now I have applied the penetrant. So now the next step is to wait for 5 to 10 minutes. So I'm going to wait for 10 minutes. I'm taking it as a dwell time. So already, as we discussed, dwell time is the time taken for the penetrant to penetrate completely into the defect. So I'm going to wait for 10 minutes. So the dwell time is completed. So now it is the time to remove the excess penetrant from the surface. So since the method is solvent removal method or solvent removal technique, so I'm using, in this technique I have to use the solvent to remove the excess penetrant. So before removing the excess penetrant, I have to take a dry cloth and I have to do the dry wiping to remove first the liquid penetrant from the surface. So you can see, make sure when you are wiping with the dry cloth, so just try to give minimum pressure, do not give maximum pressure, because which can remove the penetrant from the defect also. So at the same time I am doing the dry wiping in this specimen, T-joint fillet weld. So I am using another dry cloth. So you can see the cloth is getting red stain. So make sure, try to, as much as possible, try to clean, do the dry wiping in order to remove the maximum penetrant stain from the surface. Okay, so now I have done the dry wiping. Now I am taking a cloth, damping with, or the cloth is dampened with the remover or solvent cleaner, slightly dampened. Do not spray the solvent on the surface to remove the penetrant. So that will clear the penetrant from the deeper from the defect. So the penetrant which is inside the defect, that also will be removed. So do not never ever spray the solvent on the surface at the time of removing excess penetrant. So it is necessary that, or advisable that, to take a cloth and apply little bit solvent and in a unidirectional way try to remove the penetrant. So while you are removing the excess penetrant, make sure the penetrant is, or the stain, the red color, is completely removed. So in this specimen I have removed the maximum level of penetrant from the surface. In the area of interest especially is cleaned. So now I am taking another cloth in order to remove the excess penetrant in this material from the surface. So see here, in a unidirectional, don't do like this, just one direction, slowly, steadily, with minimum pressure you do it. I hope that I have removed. So you have to make sure that the red stain or the red, the color should not be visible during the excess penetrant removal. So I have done maximum level of cleaning in a safer side to remove the excess penetrant from the surface, and now I'm going to apply the developer which develops the indication. So this developer is having a powder mixed with solvent, so you have to shake it well to make sure that the solvent is well mixed with the powder and comes out like a paint. So I'm going to make a test shot here. So when you see here, the white is not that much visible, so I'm going to mix it well. So now you're going to see the indication. Okay, see, now you're going to get the indication here. So now we have to wait for developing time. So due to the reverse capillary action, the developer start to develop the indication. So it will take time. So meanwhile, I'm applying the developer in this specimen. So we have to wait for developing, for the developer to develop the indication. You can see the indication is well developed here. So the multiple holes are visible. So this is a cluster porosity. So you cannot see much indication apart from that. So that means this is the only surface defect in this material. So if you see here, it is slowly developing. Okay, we will wait for the developing time. So if you see here, the indication is blotting, getting bigger and bigger. So always in the penetrant testing, the indications will be bigger than the actual size of the defect. So if you see here, it's starting to develop in this region. So if you focus in this area, so you can see here, the indication is slowly developing. So if you see here, slowly it is getting developed. So that is also a kind of porosity, right? So if you see here, just one pore is there. So if you see here, there is only one pore or pinhole is there. So this one is cluster porosity, this one is pinhole, this one is also a cluster porosity. So this is how, now we have to take a photograph, then we have to measure the datum, location, length, and what type of defect we have to report it in the PT report. So different companies will be having a different reporting technique, but the basic thing is we have to fill all the details of equipment which is used in the testing, and also the details or dimensions, specifications of the test piece. Then it should also consist of standards. So mostly ASME section 5 for procedure we are using for PT, and in this case for acceptance criteria we have to go with AWS D 1.1, and since it is a pipe, we can either go with the basically with ASME B 31.3 acceptance criteria for defining whether it is acceptable repair or reject. So the inspection consists of testing and evaluation. So we have conducted the testing, we have evaluated what type of defect, and we are going to report it. And after the inspection is complete, we have to do the post cleaning. So that is what I am going to do now. So do not forget to do the post cleaning. So I am trying to remove. So I am removing all the developer, all chemicals. So I am using a solvent cleaner completely now. So if you see here, I am using a solvent cleaner to clean the surface. Okay. So post cleaning is over. After this, we have to make a report and we have to submit to the senior inspector or a QC. So this concludes the penetrant testing. So if you have any doubts, you can also contact us or join our NDT classes based on site oriented training. Thank you.